Hello, this is Nishant Malhotra from the Middle Road, OPC Private Limited. So today we are going to be discussing mean variance portfolio. So we are going to be combining two portfolios. We'll do the whole work on the Excel and we'll look at the two weights. Basically, we are taking two assets, A and B, and which is trying to have a total sum of 1, and we're going to see how it changes the expected return as well as the standard deviation. Today I'm going to be using Solver to find the mean variance portfolio. When I'm talking about mean variance portfolio, it will be the portfolio with the lowest variance. Also look at Sharpe ratio, which is a risk adjusted return, and we'll also look at a portfolio standard deviation. So we'll look at something like an expected return which is divided by standard deviation of the portfolio to give a fair idea where we are earning or where we have the highest return as a unit measure of risk. I'll also be making graphs, so I'll be teaching how to make different graphs. And to begin with, in this particular example, I'm looking at correlation, looking at 3 cases. We are going to be looking at the same case of A and B. Only thing is I'm going to be changing A and B in proportions, and this sort of proportion change the expected return as well as the standard deviation, which is going to be graphed here. I'll be using Solver, very basic function of Solver to solve the solutions. We'll be looking at 3 scenarios when the correlation coefficient is like 0.3, which is between 0 and 1. It's the two assets A and B are perfectly correlated, which is 1, and when they have a correlation of -1. Solver is a very exciting function of calculations using Solver. Let's begin. Understand how we made this graph, the mean variance graph. Look at the lowest variance. Variance is the standard deviation. Here I've taken expected return as 9% for A, B is 22. The standard deviation is 13%, and the 18% is the standard deviation is for asset B. And how much would these two be given? So you feel the portfolio A, B is anyway better. 22 divided by 18. The weightage into standard deviation square is this particular term, right? We have seen the correlation, which is 0.3 between the two portfolios. Before we go further up, I'll just look at the formulas. Weight of A into return of A and weight of asset B into return of B. The risk-free rate is 5%. Taking this is the variance. So standard deviation is under root of variance. The deviation into standard deviation of B into WAWP. This is the covariance between A and B, which is like a correlation between A and B into standard deviation A and B. So we look at different correlations. We look at correlation when it's perfectly correlated, when it's not perfectly correlated, both 1 and -1, and when it is between 0 and 1. So risk-free rate is 5%. Sharpe ratio is something known as a risk-adjusted return. It's the expected return of the portfolio minus the risk-free rate upon the standard deviation of the portfolio. When we look at this portfolio, I have a mean variance. We'll come to understand how do we calculate this mean variance. There are so many. So this can be, I can change it n number of times. I want to change the portfolio to 1, so I could put this as 0.87, which is like 87% of this particular portfolio. It means like 13% is the in portfolio B. So we see how is the expected return changed and how is the basically the standard portfolio changed. Variable, which is like standard deviation is 11.89. You look at this, the standard deviation is 11.89, and this is the expected return. Different edges, and I have plotted this. I've put in all these figures, plot in the graph. First we'll see how we plot in the graph, and then through the solver we'll see how we can do a lot of calculations. First, I keep changing this portfolio. For example, if I put 0.1, I change that at 0.1. The expected return is 20.70. First, you can select these two data points. You can go to insert, you can go to recommended charts, and you can go to all charts. We straight away go to a scatter plot. We select, I want a different data set, so I put a right click, I go to select data, remove this data. Now I want to select the data, so first I add one, name this series as mean variance. Now I want to select data X, is always the independent variable deviation, so we put standard deviation on the X-axis, and we put expected return
y-axis. This is what the graph. This is something very similar. Only difference is you can shade the colors. The reason why is outside the curve that you see at the minimum variance or the minimum standard deviation which we have got above 11. The minimum is 11.89 which you have known. You can click it. You can go to format axis. This is 0.0. So I can also put as 0.1. This would, if I put 1, it becomes 10%. I put 1 here and I click. So the curve becomes much more similar to the curve which we have here. If you want, you can go to design section. You can pick up any of these designs. So I've just picked up from the design, get exactly the similar graph, and you can stretch it up, and you can delete this and you can sort of what you want. Now we have a fair understanding how we make graphs. Once we have a graph, I want to know certain parameters. For example, I've taken Sharpe ratio, which we talked about. I've taken risk-free return as 5%. It will vary. What I've done is like I've taken the expected return and divided by the portfolio standard deviation, because I want to know what of return I'm getting for the risk which I'm taking, which is the unit risk which I'm taking. This gives me a very good idea. So if I want to put a Sharpe ratio, what I've done is I've subtracted, which you have seen, 5%, which is the risk-free rate, from the expected return and divided by the portfolio standard deviation. So this is known as risk-adjusted return. Gives you a very good idea sort of return, because risk-free rate is basically zero variance rate. That is, there is no volatility in a risk-free rate. It's an assured rate you get basically from treasury bills, or basically is backed by government securities. Now, what I want to know, so we can now look at two things. First, I want to know which is the minimum variable, since this is the minimum variable portfolio, which is the least standard deviation, at which point do I get the standard deviation? At that point, the curve changes. To do that, I can use solver. Click on the standard deviation, because this is already the formulas inbuilt. If you don't have a solver, what you need to do, you'll go to file, you'll go to options, you'll go to add-ins, go to go. At down, you have something known as manage Excel coordinates. You'll go on. You click all of them in. It depends whichever you want. Solver, analysis toolkit, is it a visual? You could put all. I've actually selected all of them. You could select whichever, but what has to be there if you're using this function. You click OK. Then you go to data and you're going to select solver. From data, it's just down to analysis. It depends on which cell you're using. Mine is 2016. It would vary exactly where the solver is. You select the solver function. Now I want to change this. So what do I want? So I want this to be minimum, this value. I want to know, select the minimum value. I want to know which are the values which will be changing. I'm changing just two values, which is the portfolio weightage. The two portfolio weightage is through A and B. So these are the only two variables I want to change. Select in that. I want to select to the constraints. So what is the first constraint? First constraint is this weightage cannot be more than 1, because we have seen this is average of A and B. We have kept it as 1. So it can shift from 0 to 1. So 1 is the maximum. We are keeping this as of now from 0 to 1. Select this next. The next is B in the same condition. So I'll put less than or equal to 1. Now the total weightage has to be 1, because it could not be. So if I take the maximum weightage could go to 2. So I have to define this stage also. This weightage is basically equal to 1. Not B has to be equal to 1. Now I go to the solver and then I solve. So putting it in non-linear, I solve the equation. It says yes, the parameters can be solved. They click OK and I get the value of 11. So automatically it'll give me 11.88. So I put 11.89. It'll give me the weightage. See, the weightage has changed. Given 0.72. Basically the weightage is 0.7197, but I have rounded off to the second digit. So you get, basically it means 72% of the portfolio would be in asset A and 28% in asset B. With this, you are being able to get the figure. Similarly, I could have also seen where I'm getting the maximum standard deviation, maximum risk. Use the solver for that. You can also use solver. For example, I want to find, and there are thousands of calculations. This is not between 1. I could take n number as 0.92, 0.91, thousands and thousands of calculations. And we have the great part is Excel is just solved it within a minute and given us at what portfolio we will get the lowest variance. Getting it at 70. At this point, we are getting a return of 12.64, but this is not the best return for the amount of risk I've taken. I can go for a higher standard deviation, but I want to know at what standard deviation I'm getting the highest return. Basically, that's why I've kept expected return by standard deviation of the portfolio. How do I do that? I again go to another cell, on it, the cell which I want to change. So I'll click here. I will go to data points. I'll go to solver, collect the data point. I'll click on the maximum value. Now I want to take the changing variables. So which are the two changing variables? Similarly, same is the weightage. I want to add the constraints. The constraints are very similar. This vote cannot be more than 1, which we have talked about. We add the next constraint. Again, this cannot be more than 1. Select less than or equal to 1. And then the third constraint is that the total portfolio should be equal to 1. The weightage of A and B cannot be more than 1. It has to be equal to 1. So that's why we'll select equal to and we'll click OK. We'll solve this equation. It will say that it's going to solve. Soon we get the maximum we'll get is 1.269. For that, the portfolio will be 0.308 and 0.692. This is a very important function we have been able to do. Similarly, we can do for the Sharpe ratio. You can try that new practice. We are doing in work. We want to find specific functions, but can also solve your linear functions. This is between 0 to 1, any of correlation, and you will see a different answer. I've done this for 0.3. We can do it for any other point. So doing it when the two assets are perfectly correlated. So look at what happens then. If the two assets are perfectly correlated, I've done the same thing. It's the same exact problem. We are adding up the two weights to 1. The expected return of asset A is 9%, second is 22% with the same standard deviation. Just changed is the correlation. The correlation one, it is always be a straight line when I'm going to be marking the expected return over the standard deviation. When you are looking at the means, say, what is the output? Output is I want an expected return. And what is the input which you want to control through the portfolio? Are you using mixing up two assets? The reason why you always mix up assets, or basically you want to diversify. Diversification reduces the volatility of the portfolio, which is the standard deviation. When you are going to be, and as we are going to be looking at the CAPM, which I'm talking about, you want to see the covariance. That's a different term, which we looked at. Covariance is nothing but correlation into the standard deviation of both the portfolios. Covariance between the two portfolios you want to see, right? It's totally perfectly correlated. You get a straight line. Slope of the curve, change in delta y upon delta x. So if perfectly correlated, which means for every change in the standard deviation, you get an absolutely proportional change in the expected return. So this is because the covariance between the two is 1. Correlation is 1. It also means the covariance. So correlation changes from 0 to 1 seen, and then it will go to also goes from 0 to -1. So we look at the things are perfectly correlated as 1, and when they are totally inversely correlated, it's -1. So this diagram gives you a stream, so you could change the graph. For say we have equated. Let's put 0.55. I put 0.55. That means 55% is in asset A and 45% asset B. I will put the values here, and you can see what it happens. Putting in the values, it will automatically pick the other value. The expected return is 14.85. Sorry, so 14.85, and the standard deviation is 15.25.
So changing the weightage, we get a different expected return standard deviation, and we see how the point comes in. It's totally linearly related.
Here I've taken the return, which is basically the correlation between the two assets, as -1. We've seen that when they're perfectly correlated, or they're correlated between 0 and 1, so that is they're partially correlated with some. And now we're looking at a case when they're absolutely not correlated. They're perfectly opposite of each other. Correlation is negative, -1, opposite directions. See that the portfolio will have two different lines, which is basically standard deviation of 0, in two linear lines, and this could be like an intercept, and that intercept return is 13.55. So always find that. Example, just to give you example, if I put that as 0.98 just to see what the return is. So if we put that, we are getting a 18% return for a standard deviation of 5.2. It's a very high return, but now I want to see at what standard deviation I'm getting, what is the minimum standard deviation. Secondly, what is its return for the standard deviation. Look at both. If I want to find which is the minimum standard deviation, which I just talked about, and again use the solver. We'll go to data, we'll go to solver. So I'm just telling you how I calculated it, because you'll not be able to know which is the minimum value, because you cannot calculate all of them. You'll put that I want to have this minimum value. You'll put this as minimum. Again, you will change. You'll talk about which are the two weights you want to change these two weights. You'll add constraints. I'll add constraint this as less than or equal to 1. I'll add this constraint again as less than or equal to 1. And this as equal to 1. The equation. We get 0. We get that the standard deviation is 0 when the mix of the two assets is at 58% and 42%. 58% for A and 42% for B. Already seen, you can use solver for multiple functions. You want to mix, you want to diversify assets. Diversify our portfolio. So usually it is seen that, and we'll be discussing in the upcoming presentation, if you have, in case of stocks, let's say you want to diversify stocks, use between 12 to 18 different stocks, you are able to diversify 90%. This Excel will be uploaded on the middleroad.org. So if you are looking at it, the middleroad.org is keep lookout for the new capital asset pricing model. It's coming under the valuation series. My name is Nishant. Hope you like this. This is the first in the series. Just keep tuned to the Middle Road